Volumes with cross-sections. So the first thing to remember is the areas of basic shapes such as rectangles, equilateral triangles, semicircles, and other shapes. Another thing to remember is the concept of areas between curves. So here we have one curve f of x and another curve g of x. And to find the area, you integrate from point A to point B in the top function minus the bottom function. The last thing to remember is the concept of Riemann sums. So here we found rectangular approximations of the area under this curve. Then here we progress to the infinite approximation, where we get the concept of integrals. So our example problem is to find the volume of the solid whose base is bounded by the curves y equals sine of x and y equals cosine of x and the y-axis. The cross-sections are perpendicular to the x-axis and they are equilateral triangles. So the first step to solving this problem is to draw the cross-section and find the length of the base. So the length of the base is defined as the top equation minus the bottom equation. So in the picture that we saw in the last step, we noticed that the top equation was cosine of x and the bottom was sine of x. You can also find this by graphing the two equations on your calculator. The next step is to find the area of the cross-section. So now remember that the area of an equilateral triangle is the side squared times the square root of 3 over 4. So remember that the side length that we found in the last step was cosine of x minus sine of x. If we plug that into the formula for the area of an equilateral triangle, we have cosine of x minus sine x squared times the square root of 3 over 4. The third step is to integrate. Now this is sort of like the concept of Riemann sums. For this, we have to integrate from the first point, the beginning point, to the ending point where the two equations intersect. And now the first thing we want to do is to find the bounds. The first one is x equals 0 because it was bounded at the y-axis. The second point is b equals pi over 4 because that is where sine of x equals cosine of x and where the two equations intersect. Now remember that in the last section we found the area of the cross-section, and now what we want to do is integrate from the two bounds of the area formula of the cross-section, which is shown here. So the final answer to this problem, when you plug it into your calculator using the fnint function, is 0.124 cubic units. This project was made for Ms. Doan's Calculus BC class by Maya Saxena, Graham Booth, and Deborah Kim.